Hello, peeps. I've remembered to unmute myself this time. We are now recording these in Zoom and not Echo 360 because there were too many problems getting that working on my computer. So we're going to have a look at week number 2 for BLAR11045, Built Environment 1. Let's share the screen for you. And we come across to our presentation that we've got here. So we're looking at human activities and the impacts we have on our environment, on our small little planet, which is a tiny dot that we live on, and we should be looking after a little bit better. We're not going after the greeny sort of stuff here. Go for the introduction here. We're going to have a look at the impact we have on everything on our planet, basically. It's obvious that what happens in one part of the, and this should say world, I just didn't get it right, can and does affect someone somewhere else in the world. So this is why the developed nations are affecting the second and third world nations. They're suffering most of the changes in water levels, etc., sea levels. We're not having a detailed talk about global warming or climate change. You'll all have your own opinions on it, and just to set the record straight for myself, because you'll all wonder, yeah, climate is changing, but I don't believe that humans are the main cause of it. We add to a much larger cycle that's occurring. That doesn't mean we shouldn't do what we're doing. I agree with what we're trying to do to improve the way we behave and live. So let's have a little look. This is just to make sure, open your own mind, okay? So don't just look at one line of information, because there's two sides to this argument about how we protect the environment and everything. And both sides tend to take an extremist view. Those who say nothing's happening are taking an extreme view, and those who say it is happening are taking an extreme view the other way. The truth is in the middle. You have to make your own mind up about that. I'll just have a quick look at the atmosphere for you to put this into context a bit. We live in the bottom couple of miles or couple of kilometres of just below the troposphere we live. The troposphere is where we fly all our planes and everything. Then you get up into the stratosphere, some aircraft up there, lots of weather balloons and things. The mesosphere is the coldest one of the layers up there. We don't do an awful lot in this area of the atmosphere. The thermosphere is warmer, because you're obviously getting further out, there's less shielding to it from the sun. We don't do much here, but we do a lot up here, where we've got satellites and things. The space station is somewhere around here. It's only about 300k up, so that's about the only thing we've got whizzing through there, really. And lots of debris, as you'll see in a minute. Just to put that thing about climate change into effect for you, interesting that they say it's existing, it's still going on, it is a problem, but just make your own minds up about where the reality actually lies. So now we come into the world, we've completely overrun most of it, really. We had the greenhouse effect. That's how this all started. Many years ago, we only talked of the greenhouse effect. We weren't into global warming and climate change back then. And basically, by pumping chemicals, especially ozone-creating chemicals and carbon fluoro, I can't remember what they are, CFCs, which were in a lot of aerosol cans and air conditioning units and that sort of stuff. That got into the atmosphere and damaged the ozone and created a hole, which you'll all know about the hole. So if you're under the hole, we're not getting proper filtering of the sun's radiation, and we all end up with skin cancers and cataracts and stuff like that. That's what the greenhouse effect was, trapping the heat inside and not radiating it out into space. So you see, I've mentioned it damages plants and animals and everything as well, and us, obviously. Other little things we're trying to do, well, transportation is an interesting question, something that we have. So throughout history, and hopefully you've all watched that population video of how it explodes in the 19th and early 20th century. We started using cars and trucks all over the place, and we've ended up with massive levels of pollution coming out of vehicles of various types. Air travel is one of the worst polluters, and I fly twice a week from Brisbane to Mackay and back, so I'm not a very good boy for that. I don't pay the $3 extra each way to offset my carbon by planting trees. If we all did that, we'd probably open our front doors one day and we wouldn't get out because there'd be trees everywhere if they really do plant them. More public transport is beginning to be based on cleaner energies. In Brisbane, we have loads of buses that are running on natural gas, which isn't as bad as diesel and fuel. Eventually, they will get to become electric, but I've got comments on the electric vehicles a bit later. Urban areas tend to concentrate the pollution because the tall buildings trap it in, and the concentration of vehicles as well. Interestingly, on vehicles, the introduction of Uber in many urban areas hasn't actually reduced the amount of traffic or the pollution. In London, where they charge you to go into the city each day, into a zone, it did reduce the cars when it first came in, but they were gradually returning to their original numbers. But Uber, you've now got thousands of cars in the area sitting there, quite often with their engines ticking over, waiting for their next ride. So an unexpected impact we got there. Town planning, we can help by designing our living areas and cities and towns so we don't rely on private cars so much. America's bad for this. Australia's not that good for it, where you hardly walk anywhere. So we'll be looking at planning later on. Let's have a look at planes themselves. So someone once said there's a new fear of flying. You're more likely to die from exposure to toxic pollutants that's in the plane exhausts than actually in a plane crash. Amazing. You can see here you get nitric oxide, and the noise is something that basically meant Concorde never took off years ago. It can create asthma, you can get cardio, all the normal things. Here's an ordinary plane taking off. Takeoff is where they normally pump out most of their visible pollutions, shall we say. So recent years, airplanes, they've killed about 1,000 people each year. But the plane emissions, according to research, kill about 10,000 people each year. That's quite a big problem, isn't it? So globally, it's estimated by the World Health Organization, there's about 8,000 deaths a year resulting from planes at cruising altitude. So that's not the takeoff and landing part of it. And when they're cruising, you can get about 2,000 deaths from that pollution during takeoff and landing, which makes up your 10,000. When the plane's at cruising altitude, way above the clouds, and we're drinking our gin and tonics and things, the wind can whisk the pollution well away from where the plane is. The pollution can fall like 6,000 miles, 10,000 kilometers away from the plane's actual route, which is quite stunning, really. If we look at cars, and everyone thinks of cars, sorry about the circle, I forgot to take it out there. Ground-based transportation contributes about half the carbon monoxide and nitrogen dioxides, and about a quarter of the hydrocarbons that we throw into the atmosphere when we start breathing. You have different types. You have particulate matter, the bits of soot and that. Bit of a problem with diesel engines, this one is. The 10th diameter of a human hair, generally the hair on your head, I'd say. Not the ones on your arms, and there are obviously people with dirty minds out there. They're the most serious because they can actually get right into our lungs. There's hydrocarbons. They react with the nitrogen dioxides, with the sun, and create ground level ozone, which is interesting that we have a problem. We've got a hole higher up in the atmosphere where the ozone's got a hole in it, and that's a problem. But too much ozone down at ground level is also a problem for us because it irritates our breathing. Nitrogen dioxides, they can cause lung irritation, which could include cancers as well. Carbon monoxide, well, we all know people sit in a garage, run their car to commit suicide with carbon monoxide when you inhale it, so that's pretty bad. Sulfur dioxide, again, something more associated with diesels, really. They react with the atmosphere, creating those tiny little particles which can get deep into our lungs. There's hazardous air pollutants and toxins, generally number of those. They're just chemicals. Apparently they've been linked to birth defects and cancer and other serious issues. And there's the ones that we generally call greenhouse gases. This is what you would see. This is in a cold morning, so you can actually see the exhausts. And to try and solve this problem, I'm basically trying to go to electrically powered vehicles, cars, buses, that sort of thing. And here's one of those little videos that talks about electric cars. He's absolutely right. I never thought of it totally in that way, but yeah, there's an interesting way to think about your electric cars. They're not quite there yet until they can be charged from the sun or the wind. Obviously, we go around in trains as well. So across the world, trains, everybody thinks they're really good. They've got a positive track record, as it says up here. One of the greenest ways of getting around. Well, the entire transport sector contributes 22% of the global emissions we're throwing out. Apparently, rails only account for 0.8. And that was between 1990 and 2009 from the European Environment Agency. Pollution produced by trains is caused by the diesel engines, and electric trains are emission-free at the point of use. Just like the electric cars, they have to get the electricity from somewhere, so the same problem exists for electric trains. And just a little thing leading into our lecture on planning, and that later on in the unit, there's a little comparison here of how much land is used by cars versus trains. So have a look at that one. Remember it's there, so you can come back to that one later on when we're talking about planning. Ships, now we can't forget ships, can we? There's a beautiful cruise liner. Look, there's no pollution coming out of those. And the number of ships, especially cruise liners, is increasing around the world. The shipping that's around East Asia, because they've got a lot of cargo ships going in and out all the time, they're producing the greenhouse gases and lots of other pollutants, and they can cause more than 10,000 premature deaths annually. According to a study in Nature Climate Change. Carbon dioxide and especially sulfur, they're two greenhouse gases, and carbon dioxide, obviously they block cars and trucks and that, they come out by burning fossil fuels, which results in the greenhouse effect, warming the atmosphere. The sulphurous particles come from the ship's fuel. Initially, cool the atmosphere, but after a couple of weeks or so, they don't compensate for the carbon dioxide's warming effect, and the particles stick around and they get in deep into our lungs again. The interesting thing about the fuel that a lot of ships use is it's the last bit that's left over after raw oil has been gone through the refinery. So they take off the lightest first. You get aviation fuel, then you get car fuel, then you get diesel fuel, then you start getting the stuff that you can use in tarmac on roads, and then the sludgy stuff that's left is basically what the ships are burning, and that's maybe why they're so black and horrible. So shipping, nah, that's not it. What about space? I mean, surely we haven't done anything bad to space. Well, the actual rockets emit some nasty stuff. There's not been much research into it yet, but you can see what's going on. Most of that in the picture is steam, by the way, because they squirt water down here to absorb the vibration of the engines taking off. Otherwise, it would destroy everything, so they use steam. But there's a lot of pollution comes out of these rockets, and they deliver them into the high upper atmosphere, and they can be floating around for decades up there. The soot that accumulates in the upper stratosphere, where the particulates and that actually absorb sunlight, and that heats the upper stratosphere, changing the chemical reaction rates, and we end up with some ozone loss for it. The other thing we've got the problem is the hardware coming back to Earth. That can affect the atmosphere as well. So that's when we re-enter, and the materials are heated to super high temperatures, and they chemically change and create more pollution going on. That's a SpaceX going up at the moment there. So we're going to space. So we've gone through them all there. So transport's an interesting thing. Let's have a little look at environmental health and air pollution. We just have a quick look here. So the burden of air pollution, you can see over here, China and India, based on this scale here, are the worst. You've got most of Russia, Siberian Russia, a few other bits up there where people don't really live that much, so we don't do anything to there. America's not too bad with the deaths. That's partially due to their improved health provisions, even though people don't get it if they can't pay for it. So Alaska, well, not too bad. Part of America, but again, not a lot goes on over there. Canada, a little bit worse. Down here, you've got apart from Brazil, your South American countries are struggling somewhat. We're okay around here. We're, you know, you can have a look here, so we're all right. China generally gets about just short of 1 million deaths a year because of it. Okay, so that's from the climate stuff. You can read this yourself. It's very interesting information. You should come back to it later on. Global deaths generally, which are linked to household pollution, etc. Acute lower respiratory disease and strokes. Look at the strokes, 36% strokes. Lung cancer at 6%. A little bit of heart disease going on. I'm trying to work out which is which. Chronic, basically pulmonary disease. That's quite a good one there. This is all due to air pollution, so you are being affected even though you think you're not. We've got pollution going on here. Generally talk through pollution. So we impact our ecosystem. Sometimes what we do has got really quick, really quick evidence. You can see it's had an effect really fast, and therefore, because it's happening in a short period of time, the cause and the effect, we can put them together in our minds quite easily. Sometimes though, and a lot of the time, they take years and years to appear, and we can't make that cause and effect connection, so we try to ignore it. Pollution's changed obviously throughout history, so very early on, soot and particles from burning wood. This would be, people living in their little huts and things in Europe, probably around the Iron Age periods. Then you start getting soot and particulates from sulphur because we start burning coal, the Industrial Revolution. And that's also when the population started to expand massively. We then got lead nitrates when we started using the internal combustion engine. Then we got chemicals from factories, CFCs and aerosols, etc., causing the holes in the ozone layer. And then we've still got, from the 1940 onwards, we've still got the radiation from the bomb tests and nuclear accidents like Chernobyl and things. That's floating around waiting to get us anyway. So we really would like, we like to think we're living here. Lovely blue skies, fluffy clouds. You can't see the pollution floating around. Or we'd like to live here, San Germano, a hilltop town in Tuscany in Italy. Beautiful, again. If you look, we've got these nice sunset clouds and colours. It's interesting because if you look at famous artists like Turner, who were really good at painting skies, the skies they painted a different colour to what we see today, and that's due to pollution. We really tend to live near stuff like this. I mean, that's so obvious. Or we might live here with all this and the traffic, and we've got that in most of our cities, really. And that basically creates that. So we've got this massive dump where we just throw things away, covering the earth with it. And that causes things like birds and animals and that to get caught up. That looks like a six-pack holder. Or you can include this one where the polar bear is beginning to starve to death here because his ice is disappearing and the warming waters, the stuff he normally eats and that isn't quite as readily available. I find that one quite an upsetting image, actually. And we go back, and we go back, and we go back, and we go back. So we looked at pollution here. Let's look at the space junk. Because everybody likes space, don't they? So let's have a look at space junk. All those launches we put up there have left old satellites and things floating around. Every time a stage separates, bolts and bits of paint and bits of metal get blown out. You get micro fragments floating around, and they'll cause damage to satellite spacecraft. It's the smaller parts moving at very high speeds which are the main problem. The bigger parts which you can see coming, you can try and avoid them. We think, oh yeah, fantastic, it's all floating around, it's not a problem. Well, the International Space Station, they've actually had to jump into the escaped Soyuz a number of times because they thought they were going to get hit by something. Some satellites have already been disabled by being hit by bits of debris up there. And there is the strong risk of this domino effect that something hits a satellite, that satellite disintegrates, creating more bits, which hit more satellites, which hit more satellites, and it could take out entire communication grids. This video, it's just amazing. This is to just show you how much these are real tracks of real debris and real satellites. Most of it's 90% of this is debris, rubbish, and this is only the stuff that's about the size of a A3 piece of paper squared, like a box that size. Smaller stuff, they just can't monitor it. They don't have the resolution in the radar net to monitor the smaller stuff. So there's loads of stuff we can't see here. So you've got stuff that's quite a way out from the planet. But look when you get close into the planet, our lower orbit stuff, where we've been putting our space stations and our early satellites and our all the stuff we've done, all the lower satellite stuff, you know, space shuttles, all that bits. And then there's all that stuff floating around further out. That's probably floating from ex-Apollo and ex-interplanetary sites, and obviously the geocentral, geostationary sort of satellites which orbit while staying over the same point of the Earth, which are all your communications and your GPS. But they've all got bits that have come off their booster rockets, and we are absolutely covered. And you've got to ask yourself, hang on a minute, how comes all our spaceships and our astronauts and all that stuff doesn't have failures or more failures because of this? Pure luck. It's just luck. We're reaching a tipping point, according to NASA, and they are beginning to play with prototype ideas to try and clean some of this up. But it's another example of humans going ahead, having fun with technology, and then suddenly sitting back and going, oh dear, what have we done? I mean, it's stunning, the amount of rubbish. So I'll come out of that. We won't need to watch all of it. So we've got a problem even off the planet. Weather. We are seeing weather patterns change. They've changed throughout geological history, and they're changing again. I mean, there are times when things like the Antarctic and everything were covered in rainforests, and now they're not, and that wasn't our fault. So they're arguing that we're getting more intense hurricanes and cyclones, but that bloke earlier on was saying that wasn't the case. You're getting precipitation, rain is increasing, causing floods. The amount of rain that's actually hitting the surface of the Earth hasn't really changed. It's just coming down in shorter periods, much heavier, and you get the floods because it can't drain away. The rain again, they reckon we're getting less of it. Droughts and fires. Well, in certain areas it's true, but other areas are getting more of it. So it's just moving around the globe at the moment. We're increasing and decreasing temperatures, so it's not all going up in temperature. Some areas are getting a bit chillier. And of course, we're getting acidification of seas. The Great Barrier Reef is an example of that, where you end up with the bleaching going on in the reef. Temperatures of seas as well are adjusting. And here's one about, water shortages we're talking about. It's nice to one about a country that seems to get an answer, not an answer, but a way forward. Now, I'm not promoting any particular agendas there. It's just interesting how they manage to get their water. Back we go. Where I've come back here. So there's a problem with weather. Talked about weather. We've got other little bits and pieces. Oh, look, we could look at some of these. Oh, well, let's have a look at farming. Agriculture doesn't get talked about a lot, although the last bloke mentioned it as being the highest user of water. It's a monoculture. Generally, it's aimed at feeding farm animals, is one of the main sectors of it. And that generates the highest amount of emissions of CO2, basically through decaying matter, and you end up with all these animals releasing wind, shall we say. And it can be compared to the total sum of the CO2 emitted by all the forms of transportation. Agriculture is responsible for lots of deforestation. About a fifth of all the emissions that come out in the decade from 20 to 2010, around 44 billion tonnes of CO2 is coming out of agriculture. This is because agriculture needs to increase the amount of space alongside enormous amounts of chemical fertilizers and water to meet the increasing demand for meat, and its products that it produces, meeting that demands are increasing in third world countries. Of course, if you're chopping trees down in rainforests to plant crops, then the trees aren't going to be there to absorb the CO2. Strangely, 95% of the soy produced in the world is eaten by farm animals, mostly bovines, and it does have the effect of making them quite a lot. A study by the university there in Gothenburg, they reckon for every 1 kilogram of meat we produce, you need 200 kilograms of CO2 emissions. So it's not very environmental. We probably should all be veggies. Apparently, there's around 700 million pigs in China alone. I think in Denmark and that they've got quite a lot as well. That's a pig for every 2 citizens. And half of the global population are piggies. To feed them, China has to import 800 million tonnes of soy, mainly from Latin America, especially from Brazilian Amazon, where they've got endless fields of it, which has destroyed the trees and the biodiversity in the area. So, yeah, your meat's causing problems. What about industrial areas? We don't say much about them. Obviously, historically, as the Industrial Revolution took hold and cities began to develop more, the industrial areas were actually in the city. And don't forget, cities have expanded an awful lot, so even if they were on the edge of a city, they're in the city nowadays. And the workers used to live next to the factories, often their housing provided by the industrialists. Nowadays, we try to keep them away from the cities and towns. We tend to have industrial parks and that's set outside. Light industrial units can have a bit of heavy pollution. They're sneaking back into the cities. Normally, they're put along major roads because they want to be near the transport to move their goods and products. Industry attracts residential development because people want jobs. So it's sort of coming full circle, really. It's very strange. Then we come into land pollution. It's basically the decline and destruction of the quality of the soil and the land surface. We're damaging landscape, which can't support the life that was there. You know about the reducing habitats of many animals around the world as we chop trees down and we build housing estates. Locally, it's the koalas, the problem for me in Cleveland. We've got solid waste, so you've got your waste tips and things we saw a picture of earlier. There's agricultural chemicals. They're sprayed on the land, fertilizers and weed killers, pesticides. The fertilizers wash off into nearby waterways and create algae problems. And then got industrial and energy manufacturing, power stations, manufacturing, and there we are, construction, creating waste. Mining has an effect, radioactive waste, not bombs, that's coming from, quite a lot often it's coming from medical uses, X-ray machines, etc. And it's leading to deforestation is a big problem. So the pollution occurs when we don't dispose of the waste properly, and people just dump them. And that happens all the time. Not to forget mentioning the mines, not a lot to say, but you've got open cast, ruin the landscape. They have problems with tailings ponds, all the stuff. They have to hold back this highly contaminated water in ponds. And as we've seen, there are examples of these failing and flooding areas and killing people. And often when these mines are done, they sneak away and don't remediate them, especially in third world countries. Underground mines, which have got a long history, when they collect disused and they collapse, you can get sinkholes. And when you're pulling all the soil out, all the ground out from underneath the ground, you end up creating big spoil heaps, and you'll see these big heaps next to mines. They often don't do anything with those. But don't forget, things are getting better because we then pollute the water. United Nations, they reckon that 783 million people don't have any clean water. 2.5 billion don't have access to decent or adequate sanitation. So these people will be contaminating their own water sources by doing whoopsies in the local streams or in the land near the stream, so it leaches into it. Long-standing water reserves are running out, and this comes to the question that you're talking about at the moment, the aquifers. So aquifers are drying up, and the pressure in them is dropping as there's less and less water. Aquifers were used without any thought whatsoever that the fact they were a finite resource and they weren't getting refilled. There's two types of aquifer. One can get refilled and one can't. And unfortunately, the Australian one doesn't get refilled, not within the lifetime of a person anyway. There's about 8 million tonnes of plastic, which is chucked into the oceans every year. That's becoming a really large problem now. Marine life suffers from the plastic. The birds eat the plastic. Increasingly they starve because their stomachs are full of plastic and they can't get anything in. Look at it, over 90% of seabirds worldwide are found with plastic in their stomachs. And the new thing happening now, well, not new, creeping in now, is microplastics. Microplastics are the plastics that have been worn down in the sea and they turn into tiny, tiny bits. But you've also got microplastics that are deliberately included in some makeup products, especially products that are to strip off previous makeup or strip off the surface layer of the skin, that sort of thing. They can have microplastics in, so all the women should stop using those. Power generation, we can't get away from power generation. We increase more and more power year on year, although we have had a couple of flat periods recently. That really means we've been burning more and more fuel, causing more air, land and water pollution. The generation needs to be near water because basically you use the fossil fuels or whatever to heat the water, to turn it to steam, to turn the turbines. Oh, no, I wasn't finished there. Come back. If we can be more energy efficient, which we're trying to do all the time, and your design of houses and construction should be energy efficient, we can improve the thermal performance of our buildings so they require less heating and less cooling. Then we won't need so much equipment. Couple that with green energy production, and we can start to control the impacts. Now, green energy works on a single house or a small collection of houses level, but it doesn't work for the entire town or city particularly. Can we rely on wind and solar? Got one of those little videos again. That's quite an interesting one. Germany have got themselves into a bit of a problem. We come up here really finely. I come back to the trees again, and I'm just going to use one of their videos for the trees because it's just spot on. Oh, sorry. Well, I meant to pause it there. I was going to say this bloke. He didn't introduce himself straight away, and he might do in a minute. He's called. His name's Patrick Moore, and he was one of the founders of Greenpeace many years ago. Let's try again. So there we go. And he founded Greenpeace. Wow. So yes, something to say. That's the end of the lecture. You have this one already to click around in the order you want to go around in. And hopefully with me talking gibberish over the top, it's improved it somewhat for you. So I now just have to find out how to stop the recording, which I think means I just have to stop the meeting. So if I can work that out and stop the meeting, there we go.